So, good afternoon, everybody. Myself, Acharya Vishwan. This is Renate Crash Course, chapter number 1 summary. I'll discuss over here. So, here the chapter is units and dimensions. So, let's start with units. So, the first question is why units? So, units are for making a uniform system which can be used by everybody. Everybody has a trust on it, and people can exchange things on the basis of this symmetrical and transparent system, and there are no disputes involved. Next is some system of units. So some standard systems were FPS, MK, CGS, and the recent system is SI, which is also called the International System of Unit. Regarding FPS, F stands for foot, P stands for pound, and S stands for second. Regarding CGS, C stands for centimeter, G for gram, and S for second. Regarding MKS, M stands for meter, K for kilogram, and S for second. And regarding the SI system, it composed of 7 basic units and 2 supplementary units. It was developed in the year 1971, sorry, and latest modified in 2018. So according to this, the rules are being made, and now there is a thing that if you measure any physical quantity, it can be measured by x is equals to nu. For example, suppose you go to the market, you buy the vegetables, so you can say that 10 kg or 20 kg or 5 kg. When you buy milk or some liquid products, you generally measure it in liters, just like 10 liters, 15 liters, or meter cube or centimeter cube. So in this way, any physical quantity is expressed to the other person in terms of n into u. Now we have certain graphs related to the x. So if x is constant, so graph of x versus n will be like this. For x versus u graph, the graph will be like this. Then we have n is proportional to 1 by u for a constant x. So we can say that on increasing the unit value, numerical value decreases, so the graph will be like this. Using the same equation, we have n1 u1 is equals to n2 u2 for a constant amount of physical quantity. For example, 1 kg is equals to 1000 gram. So here you see units are different. Here it is kg, here it is gram. Numericals value are different, but both the quantities are same. So if somebody asks you which one is heavier, 1 kg or 1000 gram, so both weighs the same. Next is system of units. So as per the system of unit is concerned, it's composed of fundamental and derived units. Fundamental units are those which can't be derived from each other. Suppose a chair has 4 legs, so each leg has got its own significance. Its role can't be played by the other legs, so that's why all of the 4 are fundamental. Whereas derived may be derived from each other as well as fundamental quantities. Next is relating any physical quantity with fundamental quantities is called dimensional formula of that particular physical quantity. So any physical quantity x can be written in terms of the 7 physical quantities, the fundamental quantities: mass, length, time, temperature, mole, ampere, and candela. So any physical quantity can be expressed in terms of these physical quantities. And here n1, n2 up to n7 are called dimensions of x in terms of mass, length, time, temperature, amount of substance, current, and luminous intensity respectively. So dimensions, another important point is dimensions of a fundamental quantity in terms of other quantities is always 0 because they are independent of each other. Next question, we can take dimension of force as m1 l1 t minus 2. Then we use certain points regarding dimensional analysis. First point is if we have y is equals to a plus minus b, then dimensions of all of them should be equal. You know that kg can be added to kg, liter can be added to liter, but kg can't be added to liter. So from there we can analyze. Second point is if y is equals to a into b, product is there or division is there, then there is no such compulsion. They follow the same rule as followed by algebra. So if y is equals to a into b, so dimensions of y will be dimension of a into dimension of b. Then we have y is equals to a raised to power n1, b raised to power n2. Then we have dimension of y is dimension of a raised to power n1 and dimension of b raised to power n2. Next point is if we have y as e raised to power x log x base 2 raised to power x, then x and y should be dimensionless. Similarly, if we have trigonometrical functions sin x cos x, tan x cos x, sec x cot x, all of these should be dimensionless. Now there is a point regarding error. So error is basically difference between true and measured value. If we write any physical quantity x, it is written as x bar plus minus delta x bar. X bar is the mean value of x and delta x bar is called the mean absolute error in x. Then we have relative error, which is the ratio of delta x bar by x bar or the mean absolute error to the mean value. Percentage error is obtained by multiplying relative error by 100. We have certain examples. If we have z is equals to x plus minus y, then z bar will be x bar plus minus y bar, but delta z bar will be delta x bar plus delta y bar. Using calculus, we can prove that if in case of addition and subtraction, mean absolute errors are added. Then if we have some functions in the form of product, so we can say that z bar will be x bar into y bar, but here relative errors are added. It's just use calculus, take log from both sides and then differentiate, we get this result. But these results are valid if error is less than 5%. This is assumption regarding that. If errors are more than 5%, you should go by the basics that percentage error is final value minus initial value upon initial into 100. So this is how you can solve it out. Similarly, if z is x by y, so z bar is x by bar plus y bar divided by y bar, and here also the relative errors will be added. However, there is a special case when z is a function of x, you use the sign that delta z by delta x is f dash x, or the first derivative of function with respect to x. Using this, you can calculate delta z, which is the mean absolute error in z. So this is how you can complete the chapter within a few minutes and can revise things clearly. I have more videos which are based on practice of this. You can search NEET PYQs on units, dimensions, measurement. Its video is available. You can search YouTube with the name NEET PYQ, units, dimensions and measurement by Acharya Vishwani. So you can have access to that, in which I have discussed, I think, more than hundreds of questions based on PYQs of NEET. If in case of any doubt, you can ask in the comment section. Thank you and have a nice day.